Didn't, that's true. I shouldn't squish him to death. That's it.
Wait, what?
Yeah, like there's tiny little.
I don't, what are we talking about?
Nothing.
Children.
You should have been paying attention, I guess, huh?
I shouldn't have.
Yeah.
Yeah.
Okay, close them all, close them up, close them up. I want phones, earbuds, all that stuff away, please. Completely away.
You're ready, coach.
Okay, all right. So let's do a quick reminder now. This is a picture of an absolute value function, right? We're gonna go back to this today a little bit. So our goal today, by the way, what we're gonna learn how to do is solve absolute value equations and inequalities. It's not hard to do. I wanna show you the steps, and I don't wanna just show you the steps, I wanna show you a way that you can understand why you do these steps, so you won't ever forget it. So we know it's a V, our parent graph, absolute value of X. The vertex is at the origin, right? The right leg of the V is just a ray starting at the origin and going up forever with a slope of 1. The left leg is just a ray starting at the origin and going up to the left with a slope of -1, right? In other words, on this function, if I go over 2, I go up 2. If I go over 1 billion, I go up 1 billion. If I go left 2, I go up 2. If I go left 1 trillion, I go up 1 trillion, right? Goes forever. Okay, so let's look at solving the equation, the absolute value of u is equal to a. Okay? What's u? Well, u could be, we're just going to call it a variable u for now, but it turns out that u is oftentimes in math a stand-in for some function of x. So it could be 3x plus 7 or something like that. Just some function that has x's. It's an expression that has x's in it, okay? Well, how do we just got through with a whole long section where we solved things graphically. We had a great trick, right? When we want to solve an equation graphically, all we had to do was we're going to graph what's on the left of the equation. So we're going to graph y equals the absolute value of u. Well, that's this right here, isn't it? Everybody agree? There's my graph of y equals absolute value of u. And I can graph what's on the right side of the equation, and there's my graph of y equals a. If I ever set y equal to, if I'm graphing y equals a constant, y equals a number, what's it always look like? Seeing people doing this, horizontal line, right? With a y-intercept of whatever the number is. So in this case, the y, we're going to say this is a right here, I guess, right? That's the y value a. We agree? And we're looking for the intersections. Isn't that all we're doing? Looking at the intersections of the blue and the red graphs. Well, here are my two intersections. Carefully chose the color. What's blue and red make? Purple. What do you know about that? Looking ahead. So what are the intersections then? We go over a, we go up a, right? Because we need a y value of a. We go over negative a, we go up a. And so importantly here, the solutions are going to be the x values, either positive a or negative a, right? Okay, so the solutions to this equation, the absolute value of u equals a, are just u equals a or u equals negative a. Okay, no big deal. You'll see that? This is always true, in fact. This is an important connection. If we start here, we start with this absolute value equation. It's always going to give us that answer every time. There's a way you kind of want to think about this algebraically. When we do algebra, sometimes we have to set things up like when we were back in Unit 2. We wanted to solve a quadratic equation. Sometimes we had to do some stuff first. We had to put the quadratic equation into standard form before we tackled it, right? This is kind of a similar type thing. It's a strategy. If we have an equation that involves absolute value bars mess up algebra. They make it much harder to do. So our strategy is we want to rewrite this equation in a way where I don't have those absolute value bars so that I can do normal algebra. This is my trick. I'm going to trade, essentially, this absolute value equation, meaning an equation that has an absolute value function in it. I'm going to trade that for two much simpler equations that don't have absolute value. both of which I can solve easily, right? Let's take an example. How about something like this right here, okay? If I want to solve the equation 4 times the absolute value of negative 2x minus 6 minus 2 equals 38, well, what can I do? First step is we're going to isolate the absolute value first. Okay, so we're going to treat the absolute value as off limits. We don't touch anything inside the absolute value function. We just have to get it by itself, right? And what that amounts to is, well, I'm just going to cover everything up inside the absolute value bars. Call it a u. We don't even need to know what it is for now. So 4 times the absolute value of u minus 2 equals 38. What are the 2 steps in order to get the absolute value by itself?
Add 2 and divide.
Good, so I add 2, right, to both sides. Then I divide by 4. I get that. Everybody agree? Okay, well, good. We got the absolute value isolated. Now, we know what to do with that. If the absolute value of u is equal to some number a, then there's 2 solutions. Either what's inside is equal to a, or it's equal to negative a. Doesn't that just make sense in terms of how we know an absolute value function works too? Right? What does an absolute value function do? If I take an absolute value of a positive number, what's it do? It does absolutely nothing, right? It leaves it alone. Absolute value of 7 is 7. If I take an absolute value of a negative number, though, what does it do? Okay, it's got to make it positive. It multiplies by -1 to make it positive, right? So doesn't it make sense then that if the absolute value of u equals a, u could either be a positive number or it could be the negative value of it. It doesn't matter. Either way, the absolute value is going to output a, isn't it? Right? So in our case then, what do? Well, we've got two possibilities. Either u is equal to -10 or u is equal to +10, right? And all I've got to do then is just go back and say, well, what's u equal to, right? U is equal to, well, that was negative 2x minus 6 in the original problem, wasn't it? Right? That's what was inside the absolute value bars. And so then I just have these 2 simple equations that I can solve. What are the 2 steps in order to get the x by itself? Add 6 and divide by -2, right? Same thing over here, isn't it? Right? So if I add 6, I'm going to get a -4 divided by -2 is +2. So one solution is x equals 2. Over here, if I add 6, I'm going to get 16 divided by -2 is -8. So those are my 2 solutions, right? No big deal. Okay. Let's try this one. In fact, I'll tell you what, why don't you guys log in, better yet, log in and go to the assignment and get a little bit of your homework out of the way for an example. Might as well kill 2 birds with 1 stone, right?